Welcome to a lesson on average rate of change of a function. The goals of this video are to define the average rate of change and then determine the average rate of change of a function. Looking at this graph here, this black line is a secant line. A secant line is a linear approximation of a function between 2 points. So in this graph, this is our first point and this is our second point. The slope of the secant line represents the average rate of change of the function between these 2 points. So when you're asked to determine the average rate of change of a function, you're really just finding the slope of a line. Remember, the equation for the slope of a line given 2 points is m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So again, when you're finding the average rate of change of a function, you're really just determining the slope of a secant line. To get a better feel for this, let's take a look at an animation. This red secant line represents the average rate of change of this black function between these 2 points. So notice that the slope of this red line is negative. Notice how the slope of this secant line is approximately negative 37, which means the average rate of change of the black function from this first point to the second point is approximately negative 37. And as we animate this secant line, you can see the slope of the secant line changes, meaning the average rate of change of the function is also changing between those 2 points. So you can see at this location here, the average rate of change of the function between those 2 points is almost negative 3, but if we progress a little bit further along this function, notice how now the average rate of change is approximately positive 2. Again, the slope of this secant line represents the function's average rate of change between those 2 points. To get a better feel for average rate of change, let's say you take a trip from Phoenix, Arizona to Los Angeles, California. And let's say you travel the 380-mile trip in 5.5 hours. We know from algebra that the distance is equal to rate times time. So if we solve this equation for r, or rate, we would have the rate is equal to distance divided by time. And this represents an average rate. So if we take the distance and divide by the time, our average speed, or average rate of change on this trip would be approximately 69 miles per hour. If we compare the time and distance traveled on our trip, the graph might look something like this. Notice how at certain times the distance traveled is less than at other times. Meaning when the graph is steep, we're traveling faster, and when the graph flattens out or doesn't increase as fast, our speed would be slower. So if we pick 2 points on this graph and sketch the secant line, the slope of that line would be our average rate of change on that given interval of time. So for example, if we look at the secant line from where we started to where we end, the slope of this red secant line will be approximately 69 miles per hour. But if we were to pick 2 different times on this trip, let's say at 2 hours and then at 3 hours, the slope of this secant line would give us our average speed during this time interval. Notice that our average speed from 2 to 3 hours would be less than the average speed of the entire trip. And you can see because it looks like we may have stopped to get gas or maybe at a rest stop somewhere around this time. Let's take a look at a few of our own examples. Let's determine the average rate of change of the given function from x equals 0 to x equals 3. Well, the first thing we need to do is determine the coordinates of the points when x is 0 and when x is 3. Once we have our 2 points, we can then just use the slope formula to determine our average rate of change. So we'll have x and f of x. So x is 0 and x is 3. Well, when x is 0, f of 0 would be 0 squared plus 1, so f of x would be 1. Remember, f of x is the same as y. And when x is 3, we'd have 3 squared plus 1, that would be 10. And we can check that over here on our graph. Here's the point 0, 1. And here's the point 3, 10. So the average rate of change of this function will be the the slope of the line containing this segment here. So the average rate of change, again, is y2 minus y1 over x2 minus x1. And just to keep things organized, I'll call this x sub 1 comma y sub 1, and this will be x sub 2 comma y sub 2. So we're going to have 10 minus 1 in the numerator, and then x2 minus x1 is going to be 3 minus 0. So we'll have 9 divided by 3, which is equal to 3. So the average rate of change from x equals 0 to x equals 3 is 3. To determine the meaning of this, it may be helpful to write it as a fraction. Remember, slope tells us the change in y with respect to the change of x. So in the interval from 0 to 3, the average rate of change of this function is, as x increases by 1, y will increase by 3. Remember, x is the independent or control variable, and y is the dependent variable. Let's take a look at one more example where we have the same function, but now we want the average rate of change from x equals -2 to x equals 1. So start by filling out our t-table for x equals -2 and x equals 1, and then we'll find f of x, which again is the same as y. So when x equals -2, we'll have -2 squared, that's 4 plus 1, so y will be 5. And then when x is 1, we'll have 1 squared plus 1, that'll give us 2. Again, we can verify that over here on the graph. Here's the point -2, 5, and here's the point 1, 2. Notice how the slope of this segment that would be contained within the secant line is now going downhill and therefore negative. Therefore, the average rate of change of this function from -2 to 1 is negative. So now we just need to determine the slope of the secant line passing through these 2 points. Again, to keep things organized, I'll call this x sub 1, y sub 1, and this point x sub 2, y sub 2. So y sub 2 minus y sub 1 is going to be 2 minus 5. And the denominator is going to be x sub 2 minus x sub 1. Well, 1 minus -2. Here we're going to have -3 over, this is going to be +3. So the average rate of change is equal to -1. But to add some meaning to this, we'll go ahead and write this as a fraction, -1 over 1. That tells us that from x equals -2 to x equals 1, as x increases by 1, y decreases by 1. So even though in fraction form it's more meaningful, when giving your answer, you always want to have it in the most simplest form, meaning your average rate of change would be -1 for this problem. And the same thing on the previous example. Even though it's more meaningful to write it as 3 over 1, you should express the average rate of change as +3. I hope you found this helpful. Thank you for watching.